Okay, guys, we're going to jump right in because it's 5 and we are needing to tackle exponents today, which can be a little bit tricky. So we're going to start by just recapping what you all sort of ended your last lesson with last week. So this is something called a literal equation. And a literal equation is when we're just trying to move things around. So you're still solving for x, but you have to just move other things around. So you're going to have lots of other variables on the other side of the equal sign. Who thinks they can tell me what my first step could be in this situation if I'm trying to solve for x? What could be my first step? Have a look. At the moment, all my x's are on the left-hand side, which is good. That's the first thing I would need them to be. How can I get the x's to be out of those 3 terms, though? Who has a suggestion for me? No suggestions coming in? I'll give you a clue, and my clue is factorization. Maybe that will help you figure out what to do. How can I factorize those 3 terms? These 3 terms, 1, 2, 3. How can I factorize them to get that x out of them? Yes, okay, so I absolutely want to make it the subject of the equation. Great, I'm going to take out the highest common factor. And the highest common factor in this case is going to be x. Okay, so we're going to take out the highest common factor. Good. And that's going to be x. So we're going to have x, and we would be left with 1 minus a minus 3. And we're going to close that bracket, and that is equal to 4 plus a. Okay, what can you tell me about this left-hand side now in this bracket? What do we have? What's happening with those two? What are they? What's 1 and minus 3? Can I do anything with those two things? Can I not? How can I? Yeah, definitely. How can I simplify this a little bit? So what's happening in, yeah, exactly, they like terms. Okay, because they both are just numbers, they're like terms. So we can actually simplify this down to saying that this is going to be x, and then in brackets, 1 minus 3 is going to be negative 2 minus a, and that is going to be equal to 4 plus a. And now if we're trying to isolate x, all we have to do is we have to divide the other side by that bracket. And we can leave it at that point over there. Now, if you wanted to, up here, you could have first simplified that, because you could have seen that this x over here and this negative 3x, they were like terms. So you could have said that that was negative 2x minus ax is equal to 4 plus a. And then from there, take out x as your highest common factor, but you would have landed up at the same point. So all the same. Does this make sense, guys? Are you feeling okay? We're not going to be spending any time on this work today. We're going to be doing exponents. This is just sort of recapping what you did in the last lesson. Why is it a denominator? Because what I'm doing at this point over here, let's just write it over there. In order for me to get my x to be isolated, I need to divide both sides by negative 2 minus a, so that those two can cancel. But what we do to the one side, we have to do to the other side. And that's why we land up with x is equal to 4 plus a over negative 2 minus a. Yes, Nawazi, how can I help? Just need to unmute on your side.
Ma'am, can you please explain again? I'm a bit lost as to how we got to the answer without cancelling the like terms, and then you cancel them at the end.
Okay, so from which step are you feeling confused from? Do you understand this part over here?
Yes, I do understand that one. The one after that one.
Okay, so the one after that one, all we've done is we took the 1 minus the 3.
X open bracket negative 20.
Yeah. Okay, so that 1 minus that 3, that gave us the -2. And then the negative a is still just the negative a. And then that was equal to 4 plus a. And then we divide both sides by that bracket so that we can try and isolate x. Now, Mother, how can I help?
Hi, ma'am. Sorry, today are we looking at exponents?
We are indeed.
Sure. Okay, sure. Thanks.
Okay. Okay, guys, if you want to take a screenshot, take a screenshot. This is just a quick recap of your last lesson. We are going to jump into exponents from here. Yes.
Hi, ma'am. Sorry, I was just scanning through this, thinking that, I was gonna understand it, but I don't. Could you
Okay.
please just run through it just one more time?
Well, from which point do you not understand it?
Ma'am, from the beginning.
From the beginning?
Yes, ma'am, from the beginning.
No, I know that's not true. I know you know how to take out a highest common factor.
It's gonna be x, I guess.
Yeah, and then you would be left with the 1
Okay.
minus a minus 3.
Okay.
And that's equal to the 4
Okay.
plus a.
Oh, that's what we're doing. Oh my God.
Yeah.
I'm so sorry. I've had such a hectic day.
No, don't
We
you
were dealing with
apologize. I just know
fractions.
that you're smarter than you think you are. That's why I was just saying, I know that you did.
Today we were dealing with fractions, but in equations type. So I was just lost. I was like, yo, what is going on?
Sure, and they're long, hey?
Yo, they're really long, ma'am. Especially when you have to write them out, and then after that you have to make sure that every sign is correct, or else the equation and the sum. Yo, it's just a lot.
It's a lot.
Oh.
Okay. All right, well, I'm glad we're on the same page now. Let's jump into some exponents, guys. So for exponents, we're going to quickly go over the different exponent rules, and then we're going to go through some of the different questions. So just a quick, cool. So before we jump into some of these practice questions, let's just do a quick recap of our rules. Do you want to take a screenshot of the first question that we started with for the day, the literal equation, Madal? Okay, quickly zoom back up there. Take it nice and quick for me. Okay. All right, so guys, get out a piece of paper or something where you can write these sort of summaries down, because they're going to help you as we go through this lesson. Our first law is that if our bases are the same, remember that these are our bases, that's our base, and that over there, that's our exponent. Okay, so if our bases are the same and we are multiplying, that's full stop there, that's the same as saying times, which is multiply, then we are allowed to add our exponents. And so we would have x to the power of 5, because we would be saying that that's 3 plus 2. Okay. Exactly. The dot is meaning times. So when our bases are the same and we are multiplying them, then we just add our exponents. So we just say 3 plus 2 and we get that 5. Okay. Next one is when we are looking at division. So remember, another way of writing this, anytime we have a fraction, another way of writing that would be x to the power of 7 divided by x to the power of 5. So when you have a fraction, it's just a division sum. And when we are dividing and our bases are the same, so again, our bases are both x here, all right? Our exponent is 7 and this exponent is 5, then we subtract them. So to get that 2 over there, we said 7 minus 5 because we subtract. And in this one, we add. Okay, I'm going to have to scroll past these two. So if you want to take a screenshot, this is your time. Remember, the most important thing with these is that the bases have to be the same in order for us to do this. So we can't have like an X and a Y. Okay. Next, this is a very similar idea, okay? If I have what we had up here, so we're looking at it in a slightly different way. So we have the x to the 7 over the x to the 5. Another way of writing x squared is writing it as 1 over x to the negative 2. Yeah, they do get hectic later, so it's like important for us to really understand these base rules. When we have a negative exponent at the bottom, if we move it up to the top, so if it was a denominator and it had a negative exponent, if it becomes a numerator, it would have a positive exponent. Exactly. We're just following the laws of exponents here. So if I had y to the power of negative 3, that's the same as saying 1 over y to the power of 3. So if it's a negative in the numerator, it would be positive in the denominator. And if it's negative in the denominator, it would be positive in the numerator. So we can just move them around. Okay. When we have a base that has an exponent and then it goes to another exponent, we are going to multiply those together. So this 24 over here came from saying 4 times 6, which gave us the 24. So we're going to multiply them together. And if I had like x squared y to the power of 3 and all of that was to the power of 3, we would multiply each one of those exponents. So we would say that that's x to the power of 6, y to the power of 9. We have to multiply all of them as we go. Just take screenshots as we go, guys, if you're not having time to write this all down. Sure. How can I help, Michael? Hello? How to take a screenshot. So it depends on what device you're working on. If you're working on a computer or a laptop or a Chromebook or your cell phone, depends on what you're working on. But maybe you can send Nelly a message and then she'll be able to help. And we can go back and get those for you. Okay, so this is a very similar idea to what I was just saying now. When we have different variables that have that same power, we're going to imagine that there would be little ones there, and we're going to say 1 times 5 and 1 times 5, and that's the same as saying x to the 5, y to the 5. We don't need to write that multiplication sign in the middle. We can just write that as x to the power of 5, y to the power of 5. It means the same thing. We don't need to have that dot, because when we have two variables that are next to each other, it means that they're being multiplied. Okay. When we start bringing some numbers into play, it's a very similar idea. In this case, if we have a fraction, so we've got this 2 over 3, the same way that we had to make sure that this power was going to both of them, we have to do the same thing for fractions. So we have to assume that there were little ones over there. And so we need to make sure that we say that that's 2 to the power of 2 and 3 to the power of 2. No, Shaden, it definitely wouldn't be a problem if you wrote the multiplication sign. It's just sometimes it can get a bit confusing for you because of when it's an X and when it's a multiplication sign. So just be careful that you know which is which. And in this case, then we've just multiplied those out. So 2 squared is 4 and 3 squared is 9. Okay. So this is the same idea as what we were talking about just now. This is the one which is the hardest thing to sort of wrap our heads around with these negative exponents. And I know when you look at it like this, it seems like it's so easy, but as soon as it's in a big expressional equation, it gets really confusing. So just always try and keep your mind with this. If we have a negative exponent, so like x to the -7, if we make it a fraction, so if we move it down to the denominator, it would become positive. And if we have a negative exponent in the denominator and we move it up, it would become positive. So basically, we're moving from the numerator to the denominator, or the denominator to the numerator. Okay.
Tiamo would like to take a screenshot. If you could please go back just a bit.
Sure. From which point?
I'm gonna ask him. Maybe right above. He has not responded yet.
Okay. Well, when I'm finished all of these, I'll
Oh,
start
number
at the
5.
top. Number 5. Okay.
Sorry.
No, it's okay. It's okay. Okay. 1, 2, 3, 4, 5. There we go. Yeah, Namaza, how can I help?
Sorry, ma'am. When the person's done taking the screenshot, can you please just go back to the recent example?
I can. Oh my goodness. Okay.
So, ma'am, for the one that you highlighted pink, oh, okay, never mind. Sorry, I just saw it now. But I was gonna ask, so you said 1 over x to the power of -5. I was gonna ask, like, doesn't it become like a negative again? But then I just remembered that, you can't have a negative exponent, and that we were switching it around to make it positive.
To make it positive,
that was my
exactly.
question. Sorry.
And when you think about it like this, just think about that as x to the power of 5 over 1, because then you can think of it as a fraction.
Yes, ma'am.
Okay.
Thanks, ma'am.
No worries. Okay. And then our last 2 things here before we jump into some questions, we've got 8 to the power of 1 is equal to 8. So that's just sort of reminding us that if we have anything to the power of 1, it is itself. Okay, because we're just saying there is 1. It is just 8 to the power of 1. Yeah, I know, Shaden, sometimes these negatives can be super nasty. I can definitely pop back and have a look. Teacher Coco, I've just seen your message. I am not able to. As soon as I start getting them on questions, I'll check the message. Okay, so let's have a look over here. So we've got 8 to the power of 1 is equal to 8. That's the same as saying x to the power of 1 is equal to x. Y to the power of 1 is equal to y. Anything to the power of 1 is itself. But if we have something to the power of 0, then it is equal to 1. And that means anything. So if I had like x to the power of 2, y to the power of 3, z to the power of 132, all of that was to the power of 0, my answer would be 1. Doesn't matter what is inside that bracket. If it is to the power of 0, it is equal to 1. Okay. Yes, I will happily go back. Just make sure you've got a screenshot of these last 2 before I pop back up. I know it is battling, hey. But it's cool. The power of 0 is really helpful. Well, it's sort of is doing now something, and it's also sort of doing quite a lot, because if it's making it to the power of 0, it's changing all of that to a 1, which is pretty cool. But we can see it if we look at it like a pattern. So think about it like this. This is quite a cool way of thinking about it. If I have 2 to the power of 3, 2 to the power of 2, 2 to the power of 1, 2 to the power of 0. Okay, who can tell me what 2 to the power of 3 is equal to? What is 2 to the power of 3 equal to as a number? So 2 times 2 times 2, what does that equal? No, 8. Thank you. Thank you. It's all 8, Michael. It's okay. Okay, what is 2 to the power of 2? So what's 2 times 2? 4. Beautiful. Okay, 2 to the power of 1. It's just 2. And do you see how each time here, what we're doing is we are dividing by 2. And so what we're doing here is, again, we are dividing by 2. And so 2 to the power of 0 is equal to 1. And then we can get even fancier if we wanted to. And we said, what's 1? Oh, no, sorry. 2 to the power of negative 1. So we're minusing 1 each time. And again, we are dividing by 2, which is 1 over 2. And so equations, maths, numbers, the whole thing about maths is that it's just working on patterns, just trying to see what the familiar patterns are. So all of this exponent work is just patterns. Okay, now that we have sort of a basic idea of our different exponent laws, we're going to quickly catch up on some questions. So let's go all the way to the top here and start making our way through. So some of these are going to feel nice and easy, and some of them are going to feel a little bit more stressful. But when you're working through these, the first thing you need to do is you need to think about your numbers. Okay, so you're going to be thinking about those constants, and then you're going to be looking at your variables, and you're going to look at each variable separately. So if you have a highlighter, I would recommend you highlight away exactly, Nelly, so you're going to SNV, signs, numbers, variables. Okay, so for those of you who have not heard that before, SNV, signs, numbers, variables. Okay, so in this case, both of them are positive, so we don't care, like it's going to be a positive answer, no worries. Numbers, we've got 2 6s, so we're going to say 6 times 6, and what is 6 times 6 going to give us? What is 6 times 6 going to give us? 36, beautiful. Okay, then we look at our variables, so we're going to start with our x's. We've got x to the 2, and then we've got this x over here. What is that going to become? Exactly. So think about your law 1, our bases are the same, and we are multiplying. The dot is just another way of saying multiply. Good, x to the power of 3. We can't forget that there would be a 1 there. Okay, then we look at our next variable. We've got y cubed, and we've got y to the power of 4. Beautiful, guys. Nice. Y to the power of 7. 100%. Beautiful. Okay. So now that I helped you with the easy one, I'd like you to give the second one a try for me. I want to warn you that there are some traps waiting for you in the second one, but I want you to give it your best go. And then I want you to try and tell me what number you get. So tell me what answer you get when you're working through question 2. Put your answer in the chat for me, and we'll see who gets this right and who gets this wrong. I'm very excited to see. Well, Maza, do you have an answer for me?
Ma'am, not necessarily an answer.
Okay.
But I was going to ask. So like, oh, everyone coming in with the ones. So, I was going to ask. So for the 3p to the power of 0, the 3 also has an exponent of 1, right?
The 3 has an exponent of 1. Yes.
Oh, okay. Then I'm guessing I'm done. Sure.
Okay.
So goes with the 2, right?
Yep.
The 2p. Okay. Period.
So far, I have not seen an answer I'm looking for here in the chat. I still haven't seen the answer I'm looking for.
Kehorati is
Oh,
almost.
I have just seen the answer I'm looking for. There we go. Now we're getting on track, guys. Okay, let's have a look. So this one was sneaky. So we have to look at what was to the power of 0. So this whole bracket was to the power of 0. Cool. That means that that whole bracket there is equal to 1. Okay, nice. Plus 2 bracket. Now inside this bracket, the p is to the power of 0, but the 3 is not to the power of 0. So inside that bracket, that's actually 3 times 1, because the p to the power of 0 is 1, but the 3 is itself. Sorry, let's try and move the screen a little bit. Okay, so in here, we've got 3 times 1 to the power of 2. So what that actually means is we've got 3 to the power of 2. So we've got 1 plus 2 times 3 to the power of 2. 3 to the power of 2 is 9. I'm just going to have to move up here because my writing was too big. So it's 1 plus 2 times 9, which is 1 plus 18, which is 19. So a couple of you got there, which was great. No, Wazi, how can I help?
On my answer, I don't think it's right though. I'm still trying to understand, where did you get the 18 and 19?
Okay, so the 18 came because I had this 3 that was to the power of 2. This 3 over here was to the power of 2. That 3 to the power of 2, and that became 9. And then this together, this 2 times 9, that gave me the 18.
Oh, I guess my answer was way too wrong because I got p plus 36p.
So the thing is that the p's land up going away because they were both to the power of 0, which made it 1. But remember, these are really tricky sums. These are there to try and trick you. So as long as you're learning from it, that's all that matters.
Okay, thank you, ma'am.
Okay. Guys, those of you who got it, nice job. A big, big congrats. It was a tricky question. Question 3 has its own trap in it. The main trap of question 3 is you need to be careful with your signs. Okay, so the main trick with question 3 is you need to be careful with your signs. I want you to think about this number here as -2. So think of it as a whole thing. Think of it as the number -2. Hopefully that will help. Okay, give it your best go, and we'll see.
Hi, ma'am.
Hi.
How are you?
I'm good. How are you?
I'm good. So,
How can I
ma'am,
help?
in front of that -1, like, it's the -1 then the open bracket. I just did it. But would you count that -1 with the exponents as well?
No. So think about it as -1
Yes, ma'am.
times that bracket.
Okay, so no exponent in front of that -1. Yeah. Thanks, ma'am.
Okay. Oh, Mateo, be careful. I'm going to write something here which might help you guys. I want you to think about it like this. Think about what that would be. There are lots of traps in this question. Lots and lots of traps in this question. TJ, how can I help? Hello? Okay, let's break this down step by step. The negative on the outside of the bracket, we're going to keep it where it is for the moment. And we're going to just focus inside this bracket at the moment. So I've helped you out over here. We've got -2 to the power of 4. So that's the same as saying -2 times -2 times -2 times -2. Okay. And that is going to give us, first of all, it's going to give us a positive because we have 4 negatives, and 4 negatives is going to give us a positive, and it's going to give us 16. So that's what my -2 to the power of 4 is going to come. Then we're going to do each of our variables here. So we're going to have x to the power of 8, y to the power of 12. And then all we need to do is take this negative, which was chilling outside our bracket, and move it and multiply it in. And so our final answer just becomes, sorry, just trying to move the screen a little bit. Our final answer is just going to become -16 x to the power of 8, y to the power of 12. So now if you guys messed up the number and you didn't get -16, but you got the x to the power of 8 and the y to the power of 12, that's great. That's already 1 mark. So that's not the end of the world. But let me know how this went. If there's something you don't understand, just shout. That's how we learn. We learn from mistakes. Yeah, Namaza, how can I help?
Hi again. Sorry, ma'am. 2 to the power of 4.
Mm-hmm.
Is that 16?
Mm-hmm.
It's me with my maths wrong. Sorry, ma'am. Because I was like, it's 32. And I was
That's
like,
2
so
to the power
determined.
of
I was
5.
like, yes. Yes.
Yeah.
I was so determined. I was like,
That's okay. It happens to the best of us.
thank you, ma'am.
Okay. Okay. Let me move down so you can give question 4 a try. Now, question 4 is quite similar to question 3. So if you made a mistake in question 3, you should be able to resolve that mistake in question 4. Let's see. Junior, how can I help?
Hello, ma'am.
Hi.
I was just asking, when we had a number 3, we had -6, negative open brackets, -2x squared, y cubed, close brackets 4. Ma'am, what happens? Isn't there's 2 negative signs?
Yes. Okay. So the thing is that negative that is outside the bracket, this negative over here, that negative, we only take that negative into account once we have dealt with everything in the bracket. So we first simplify everything inside there, and then we multiply that negative in. Okay.
Yes, ma'am.
Okay. Okay, we're getting some answers coming in. Okay, so for paid maths and bed maths, for those of you who don't know what that's talking about, I'll write it over here. So it's just talking about the order that we work in. So it's brackets and then exponents, division, multiplication, addition, subtraction. But these two, we'll work left to right if they are all we have. Okay, let's try and work out this question. So we're going to start by just working inside this bracket over here. So we've got, think about it like this. And remember, you can use your calculators. You've got -2 to the power of 7. That means we're going to have an odd number of negative signs. So it's going to be a negative answer. So we're going to have a negative sign, and then we're going to have a -128. Now we're going to deal with each of our variables. So we're going to have x to the power of 14, y to the power of 21. And now we can multiply these two negatives together, and that's going to give us a positive. So we're going to get 128, x to the power of 14, y to the power of 21. So just use your calculators to help you as you're working through these questions. So Shaden, it depends on where in this test this question would be. It could be anywhere from 2 to 3 marks. All right, if you want to take a screenshot, take a screenshot, and we are going to try some slightly different questions from here. So the negative answer in question 3 was because we had this minus sign outside the bracket, and a negative times a positive is a negative. Whereas in question 4, we have 2 negatives, and 2 negatives become a positive. Okay, question 5. Question 5 is when we need to... You've gotten every question correct for everything. I'm so proud of you. Well done. Nice job. Question 5 is when we have to start playing around with our numerator and our denominator and sort of simplifying them in their own ways and then bringing together the power at the top. So I'm going to help you a little bit with this one, and then I'm going to let you do question 6 by yourself. Okay. So yeah, there we go. So for question 5, the first thing we want to do is we want to have a look at our numerator, and we want to simplify it, and we want to have a look at our denominator. And once we have got both of those, we can start looking at the power. Okay, so if I'm looking at my numerator over here, I can say I've got, look at your, remember signs, numbers, variables. So we can first look at our numbers. We've got 3 times 2, that's 6. And what would my A's be? What would my A's be on my numerator? If I have a to the power of 3 times a to the power of 5, what is that going to become? A to the power of 8, great. Oh, I rhymed. Over 12, a to the power of 10, b. Okay. I would like you, for the moment, I'd like you to ignore this 2 up here. And I want you to try and simplify what is inside that bracket. So that's all I want you to focus on right now, is I want you to try and simplify what's inside that bracket. So look at your signs. In this case, they're both positives, so it's fine. Look at your numbers. How can I simplify 6 over 12? And then look at your variables and think about how you can simplify them. So think about your numbers and your variables, and then tell me what you're going to land up with. And then once we have simplified inside that bracket, we can start looking at the 2 on the outside. And remember, guys, you have your calculators to help you. You have a number here, which is 6 over 12. If we're wanting to simplify that, we can just put 6 over 12 in our calculator and push equals. So Michael, that's a V. So it stands for signs, numbers, variables. And it's just a way to help us remember what we should be thinking of as we work through questions. So we first want to look at our signs, then we want to look at our numbers, then we want to look at our variables. Okay, so if I simplify 6 over 12 in the calculator, I'm going to get 1 over 2. So I'm going to get 1 over 2. All I have done there is simplify those numbers. Okay, Now we're going to look at our variables. I've got a to the 8 at the top, and I've got a to the 10 at the bottom. That means that they are bigger at the bottom. So I'm going to have a to the 2 at the bottom, because that's where they're bigger. So that's looking at our a's. Then we're going to look at our b's. We only have one b, and that b is chilling at the bottom. And that is all to the power of 2. Now that everything is simplified, we can take in that square to everything. So 1 squared is just 1. 2 squared is 4. A squared to the power of 2 is going to be a to the power of 4, and b to the power of 2. If you said 2 instead of 1 over 2, you would lose the marks for the numbers. But if your variables were still in the right place, if they were still in a denominator where they should have been, you would have gotten some marks. But if you wrote everything just as a numerator, then you would have gotten no marks. Yes, hi, how can I help?
Hi,
Hi.
why would you not square the 1?
So you do, but 1 squared is just 1, because 1 times 1 is 1.
Yeah. Sorry, ma'am, it's been a long day.
No, it's okay. It's okay. How do we get rid of the 8 and the 10? So the 8 and the 10, what we did was we basically said this 10 down here minus that 8, and that gave us the 2 left at the bottom. Because if I had 1, 2, 3, 4, 5, 6, 7, 8 A's at the top, and 1, 2, oh goodness. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 A's at the bottom. These ones would all cancel with each other, and I would just be left with 2 A's at the bottom. That's why we have the A squared in our denominator. Okay. Nowazi, how can I help?
Ma'am, I'm struggling with the network, so I'm still lost on the first step. I'm asking if you should just first start with the bracket using board mass, then you go to the third step. That's when you start multiplying using the exponents that's outside.
Yes, exactly. So our first step, all we want to do is we want to simplify our numerator and simplify our denominator, and then we want to start simplifying the fraction.
Oh, okay. Thanks, ma'am.
No problem. For the question that came in the chat, yes, if you had, so let's say I had x to the power of 4 over x to the power of 7, because my exponents are bigger at the bottom, that would be 1 over x to the power of 3. So wherever they are bigger is where that would end up being, if that helps. Okay, cool. Okay, guys, this one's mean. I'm not gonna lie. But the first thing we want to do is we want to have a look, and we want to say where every time you have any kind of exponent question, the first thing you want to do is grab a highlighter or a colored pencil, or if you're working in pen, you want to get a pencil, something that's different. Okay. Oh, sorry, I'll go up so you can take a screenshot. There we go. Okay. So whenever we have negative exponents, the first thing we want to do is we want to move things around. Okay. However, when it's to the power of a negative exponent, sometimes it's in our best interest to multiply it in, because otherwise we have to move things twice. So let me show you what I mean. In this question, we know that if we had like x squared over y cubed, and that was to the power of 2, we're going to multiply that 2 into both of them. So that would be x to the power of 4 over y to the power of 6. We're going to use that same logic now. Okay, so we're going to say, well, what is negative 4 times negative 2? What is negative 4 times negative 2? Who can help me out? Yeah, it's positive 8. Done. Okay, next. What is 8 times negative 2? What is 8 times -2? -16. Excellent. Over. What is 2 times -2? Beautiful. What is -3 times -2? Beautiful. Okay. Now you've got two different approaches that you can take from here. The first thing you could do is you can say, well, this one is negative and this one is negative. So they need to flip around. Okay. So we can say that that's the same as saying x to the power of 8 times x to the power of 4 over y to the power of 16 times y to the power of 6. So all we've done is we took this negative and we moved it to the bottom, and we took this negative and moved it to the top so that they became positives. And then our last step here would just be to simplify. So we would say that that's then equal to x to the power of 12 over y to the power of 22. So if you do it like that, it's actually not so bad. If you just do it sort of step by step, it's not so stressful. Yeah, not so bad, hey? Oh, good. I'm so glad you've enjoyed today's lesson. That's great. We've still got time to keep that brain on. Okay, if you want to take a screenshot for me. And we're going to jump into another question. I feel like I'm winning you over, Michael. One day at a time. Yeah, so Nwazi, if you have negative exponents, you just need to flip them. If it's a numerator, it needs to move down, and if it's a denominator, it needs to move up. Okay. Cool. Okay, so what we're going to look at now is we're going to be doing a very similar thing, except all we're going to start bringing in is our bases are just going to be numbers instead of variables. Okay, but I don't want you to panic. I want you to think about it in the exact same way. So in question 1, we've got 2 to the power of x times 2 to the power of x. Our bases are the same. Okay, our bases are the same. When we are multiplying, what do we do to our exponents if our bases are the same? What do we do to our exponents if our bases are the same? We add them. Okay, so we say x plus x. What is x plus x, guys? What is x plus x? 2x. Yes. Okay. Now, I know that writing this step here might seem silly, and you might be like, oh, it's so stupid. I know that's what it is. But sometimes it really helps us figure out what we're doing, and so we don't land up writing. A very common mistake here is that people write x squared like that, which is definitely not what this is looking at. Okay. Okay. We don't multiply the bases the same way that we don't multiply the bases if we had x squared times x cubed. The bases stayed the same and we just added our exponents. So when our bases are the same, they stay the same, we just add the exponents. No problem. So in this one, we've got the same situation. Our bases are both the same. Our bases are 2. And now we have an exponent of x and we have an exponent of 3. So how could I write that? Careful, careful. Can I simplify what I've written on the board? So some people are saying I can simplify that to 3x. Can I? Namaza, can you answer me?
Sure, ma'am. I want to say yes.
What?
I honestly, no, you can't simplify that.
And
No.
why can I not simplify them? What are
'Cause,
they?
ma'am, they're not the same thing.
They're not the same. They're not like terms. Guys, they're unlike terms. We can't add them. If you were given a normal algebraic question that said x plus 3, you guys would be like, yeah, that's x plus 3. I can't do anything. But when it becomes exponents, our brain is like, we should do something, but you can't. They're not the same. So we have to leave them.
Sorry, ma'am. I was gonna ask. So in some occasions, I know that in a test, like in a spot test that we just recently wrote, we had this one equation where the exponents were the same, but the bases weren't. And then they said that we could multiply them if that was the case. Is that true?
Yeah, so
Like
it
we could
depends.
multiply the bases.
It depends on what the situation is, but for the most part, yes, if they're both going to the same exponent, you can work around it.
Okay,
Okay.
sure.
Okay.
Thanks.
Okay, let's have a look at this next one over here. So now we've got 5 to the power of 3 and 3 to the power of 5, and both of those are to the power of x. So now be careful, because we've got these bases chilling, and then we've got this power. So how do you think I can answer this question? I want you to think about what both of those would be. Who thinks they can give me an answer to this question? Think about what we do when we take a power to a power. What do we do? If I had, like, think about it as a smaller example. If you had x squared to the power of 3, what would we do? Would we divide? That would become x to the power of 6. So think about what we did there. Yeah, we multiply. Okay. And so if I'm multiplying and I'm saying 3 times x, that's just going to give me 3x. So I'm going to have 5 to the power of 3x times 3 to the power of 5x, because all I'm doing is I am multiplying those two things together. So I'm saying 3 times x, which gives me my 3x, and 5 times x, which gives me my 5x. Okay. You guys are doing really, really well. Okay. This is going to be the last one we're going to deal with today. This one, some of you might be able to do this in your head, and some of you might struggle. So for questions like this is when our calculator is our friend. So grab your calculators. Let's put in this number 81. So I'm just going to put the number 81 into my calculator. Okay. I'm going to push equals. I'm going to just write what I'm doing over here. So we've put 81, question 4. So 81, and then I pushed equals. Sorry. It doesn't seem to want me to write on the screen anymore. It's so weird. It's like creating these weird pictures on my side. Okay, so we pushed 81 and then we pushed equals. Then we're going to push this button over here that says shift. Okay, so we're going to push shift. And then we're going to push this button over here, which kind of looks like full stops and commas. And then above it in yellow, it says fact. We're going to push that. So it says fact in yellow. And when you push that, you will be able to see what the prime factors are. So this will simplify down to 3 to the power of 4 to the power of x. Good, good. So now we know how to do that into our calculator, which will be helpful. Okay, so we're going to say 3 to the power of 4 to the power of x. And then we just need to do the same for our 27. So how do we get 27 as a prime base? What is that 27 going to be? So as a prime base, 9 times 3 absolutely is 27. How can I get it in primes though? Good. Okay. So then all we have to do is we have to multiply those two together and those two together. And I will ask Teacher Coco to start your next lesson with this question, because we have drastically run out of time and you still have to do your poll. So I'm gonna have to leave you there, guys, but I will ask Teacher Coco to finish this off with you in the beginning of your next lesson. And I hope you have a lovely afternoon.